This is part 2 of test review. In this video, I'm going to go over problems 6 through 10. So number 6, a science teacher is teaching her class about evaporation. To demonstrate the idea, she leaves a 24-ounce bowl of water outside in the hot sun. The water evaporates at a rate of 3 ounces every 2 hours. At this rate, how many hours would it take for all the water to evaporate? So first thing, do they give us a percent, or are we looking for a percent? Nope. So we have ounces and we have hours. So we do not need a 100. Ounces over hour. And then we're going to start with the rate, or the information they gave us. So notice how this one has our rate or our info in the middle, not at the beginning like the others. So always look for rate, ratios, that goes in the middle. So 3 ounces goes on top, 2 goes on the bottom. And then we want to see how long it will take for 24 ounces to evaporate. So 24 goes on top. And then my arrows point to my X. That means we're going from left to right. And I know that 3 times 8 is 24. So I do the same to the bottom. And 2 times 8 is 16. Alright, next one, number 7. In a recent poll of 125 people, 75 of them said they like hot chocolate. What percent of the people polled like hot chocolate? So first thing, do they give us a percent? Are we looking for a percent? Yes. So I'm going to have 100 in my proportion. We don't know what the percent is, so we're going to put X on top. And then we need to see what the percent represents. Well, it says that what percent of the people like hot chocolate, so I'm going to make my numerator represent hot chocolate. And then the bottom would be my total. And then remember, the total always has to be bigger than the numerator. So 125 is bigger than 75, so that means that goes on the bottom. And it also makes sense. They're asking 125 people, which is my total. 75 of them like hot chocolate, so they go on top. And then we solve. So I don't know if there's a relationship, so I'm going to go ahead and just do bat and ball. My bat will be where I have the 2 numbers. So step 1, 100 times 75. And that's just going to give me 75 with those 2 zeros at the end. Step 2, we then divide by our ball, which is 125. So 7,500 divided by 125. It can go into 7, it can go into 75, but it can go into 750. Let's see how many times. I'm going to try 5. 5 times 5 is 25, carry the 2. 5 times 2 is 10, plus 2 is 12, carry the 1. 5 times 1 is 5, plus 1 is 6. So I think I can fit in another one. Let's see what happens if I add another 125 to it. 5 plus 5 is 10, carry the 1. 2 plus 2 is 4, plus 1 is 5, and 6 plus 1 is 7. So it goes in 6 times. We get 750. 0 left, and we bring down our 0, and then 125 cannot go into 0, so we put it at 0. So my answer would be 60%. And then just like before, my percent cannot be bigger than my denominator, so I could eliminate A. 50% would be half of this, which would be about 60. We have more than that, so it would have to be between B or C. So that once we do our work, we end up with B. Now you could also have simplified. 75 divided by 25 gives us 3. 125 divided by 25 gives us 5. And then 5 times 20 gives us 100. So 3 times 20 gives us our 60. So either method works. Number 8 is one of the easiest problems that you will have on your test. Casey is making a cake recipe. The ratio Ratio is important because the order matters. The ratio of tablespoons of sugar to butter is 4 to 8. So sugar to butter is 4 to 8. Remember, we can write it as a fraction, 4 over 8. Which of the tables below could represent the correct ratio? Well, if you look at the relationship, how could you go from sugar to butter? How could you go from 4 to 8? And remember, we're only focusing on multiplying and division. No adding, no subtracting. So that means we would have to multiply by 2. So to get from 4 to 8, we multiply by 2. So we're looking for a table where the relationship is also times 2. And it has to work for all of them. So if I look at D, I'm going from sugar to butter. I have to multiply by 2 to get the butter. 2 times 2 is 4. Yes. 4 times 2 is 6. No, so it can't be D. B, 2 times 2 is 4. Nope, that's wrong. 1 times 2 is 2. Yes. 3 times 2 is 12. No. So then A, 1 times 2 is 2. Yes. 5 times 2 is 10. Yes. 6 times 2 is 12. Yes. So my answer would be A. So just look at the ratio. How do you go from 4 to 8? And then look for that relationship on each table. Number 9. The ratio of right-handed students to left-handed students in the 6th grade is 3 to 2. If there are 90 left-handed students, how many right-handed students are there? So we're looking for the right-handed students. So they don't give us a percent. We're not looking for a percent, so we just need to look at our units. What are we comparing? And then notice how they gave us our keyword ratio, and it's going from right-handed to left-handed. So I'm going to keep it in that order. Right-handed to left-handed. Those are my units. And since it's 3 to 2, I'm going to change that to a fraction. 3 will go first, and 2 goes on the bottom. 3 represents my right-handed, 2 represents my left-handed. And then my other number is 90, and it represents left-handed, so it's going to go on the bottom. And we're looking for X up here. So I'm going to do bat and ball. I'm going to pretend I have no clue how I can go from 2 to 90. So my bat would be 3 times 90. So 90 times 3. 3 times 0 is 0. 3 times 9 is 27. And then step 2 is to divide by 2. So 270 divided by 2. 2 goes into 2 once. We get 2. Bring down to 7. 2 goes into 7 3 times. We get 6. 1 left over. Bring down to 0. And then 2 goes into 10 5 times. So my answer would be 135. And remember, with whole numbers, my decimal is all the way to the right. So 135 decimal. And then don't forget your sign, write it and bubble it in. Last one, Michael's pencil is 13 centimeters long. How long would this be in meters? So we have one number, we're going from centimeters to meters, so we're going to convert. So this is where we use our chart. We're looking for centimeters to meters. And right here, I can see that 1 meter, so 1 goes on the bottom, equals to 100 centimeters, so that goes on top. And then we look back to our problem, and we have the number 13. And since it's centimeters, that's going to go on the top. And we're looking for this. So then there's no relationship from 100 to 13. So I'm just going to do bat and ball. So my bat would be 1 times 13 divided by my ball, which is 100. So if I multiply 1 times 13, I get 13. and then I divide by 100. Notice how this fraction, you should be able to change it to a decimal. My answers are in decimals. 13 hundredths is the same thing as 0.13. Also, if you have 13 and you're dividing by 100, that's the same thing as moving your decimal 2 places to the left. There's 2 zeros, and then we're dividing, so we want our answer smaller, so we would move it to the left, and we get 0.13. So there's 2 ways you could have done that. So my answer is B.